Okay, I'm going to show you today how to use the Pangeo framework, which is an open architecture for scalable computing, uh, how to use it for some remote sensing data, to process remote sensing data, to look at changes over time. And here we're going to look at a use case for expansion of illegal gold mining in Peru in this Madre de Dios region. And I did this work with Joseph Kellendorfer at Earth Big Data, and I'm from the USGS. So when you're interested in some region, you might want to start out by finding out what data is available. Um, this all starts off, by the way, with cloud optimized data available on the cloud. And in this case, we've used Stack, which is a metadata standard. And we can then search. The metadata is also on the cloud, so different people can stand up search services. And here we're going to go to this search endpoint, and we're going to look for all the data between January 1st, 2017 and the present. Here we're going to specify that we're looking for Sentinel-2 data, so optical data. And we're looking for a particular zone on the Earth, particular cell in this MGRS grid system that is where the Madre de Dios region is contained. We could also search by a bounding box. If I execute this search, I find out we get the results back very quickly. Lightning fast. It's using Elasticsearch. We get back 445 items. And now if we just add one thing to the search, now we want to just find cloud cover less than 5%. If we do that query, so basically clear images, we only get back 37 items. So this is a region that's quite cloudy. And therefore, if we want to look at a time series of how things change, it's useful to look at other remote sensing products like Sentinel-1. So here we're going to open up a cube of data, so a time stack of remote sensing data from Sentinel-1, which is uses SAR. And so this is a we're loading a particular degree square here from a bucket. And we can go down first. We can actually fire up a cluster to work with this data, so we can work with more than one processor on the cloud. And in fact, here we have 23 processors that we're going to use, and we're going to, so 23 processors for 1 minute costs the same as one processor for 23 minutes. And, it costs the same on the cloud. So let's see what this data set looks like. We've just read the metadata at this point. We've got 115 time steps, and it's about 5,500 pixels in X and Y. And we can see how big this data set is. It's 13 gigabytes. So we're just going to, we're not going to download it. We're just going to process it directly from the object storage here. So anyone could reproduce this workflow. So let's take a look at the data. We can do that by just taking the data set and saying hvplot using these Holoviz tools, and we want an image, and specifying some other parameters here. If I execute this cell, you can see the workers start reading data and computing basically the data necessary to visualize this Sentinel-1 data. And we're also specifying that we want an Esri tile service in the background, so we get this nice little map. I'm going to turn off this hover tool for a second. I want to zoom out. Actually, I can choose this wheel, this little wheel zoom here, and to zoom out, so we can see where we are in Peru. And then we can go back. We can just reset to the original imagery, and you can see when we rescale, whenever we change the resolution, on the back end it re-renders the image and just delivers back those pixels that we're asking for. So which makes sense, right? So if we zoom in on this region, you can see it's pixelated at first, but then it reads the rest of the full resolution quite quickly. All right, let's see. So so just then with a simple we can just zoom in to a particular region just by doing a selection. And then we can, by indices here, and then we can execute that same cell and basically just say that we want a widget type scrubber, which adds this little animation control at the bottom. So here in this region where we see this, if you keep your eye on this spot here, in fact, maybe I'll just, so here's the beginning of the record. We could use this slider. We can use this time stepping tool. In the interest of time, I'm just going to show you a few. I'm going to grab that slider. Move it to the middle here so you can see this region here expand, and if we move it to the end, you can see it expand a little bit more. But if we want to see the details of how that works, we might want to have some kind of interaction where we click and see a time series, and that's what's enabled by this next few lines of code. We basically create this image, we define a time series function, and then we link those two together. And we tell it how to make a little dashboard application. So again, this is all just a few lines of code in a notebook. We didn't need any web developer here. And here's this image. We can again turn that hover off. If we're interested in this region over here, for instance, we can just click in this cell and see the time series of the SAR data from that region. And you know, when we do that, we're looking at 4 different curves here from ascending and descending, horizontal and vertical polarization of the SAR data. We can see really when this occurred back here. And in the hover tool, of course, if we use that, we can see that this occurred between, say, June 2018, this deforestation, and February 2019. So it's a really powerful tool for exploring SAR data, and I really want to make the point here that, you know, we can use this system for just about anything. Here we used it with just a few lines of code to look at remote sensing data and create something that looks almost like a web application. In fact, we can deploy that web application to the cloud without anybody seeing any of the underlying code, so they can just use it. So that's quite effective too. And again, you know, anybody can reproduce this. We didn't download any data. We used completely open source tooling, so it could be repeated. It's completely reproducible. Thanks very much.